What's up, geometry students? Welcome to Flack Math. We are going to review test 15A so you can take test 15B and feel nice and confident, warm, and safe inside. Let's do this. Sorry, I don't know what to do on camera. I don't know what to do with my hands. I don't know. Let's just do this.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so let's get right into it. Number one, a swimming pool is in the shape of a cylinder. Whatever. Height of 5 feet and a radius of 9 feet. 9 feet. How many cubic feet of water can the swimming pool hold? Find the volume of a cylinder. You know how to find the volume of a cylinder or any kind of prismy thing. Area of base times height. All right, well, the cylinder's base is a circle. So pi r squared times height. 3.14 times 81 times 5. Let's do it. Calculator. 3.14 times 81 times 5 equals 1,271.7, what is it, feet? Cubic feet. So 1,271.7 cubic feet. Boom, done. That was awesome. Well done. Is my eyebrow like crooked, sticking up weird? There we go. All right, number dos. That means two. I'm bilingual. Si hablo español. Yola. Number two, find the measures of Q, R, and S and PQRS. So if this is an isosceles trapezoid, that means that all these angles are going to, so this is also going to be 103 degrees. So this is 103 degrees. So angle Q equals, measure of angle Q equals 103. All right, so, and these guys, since they're parallel, these are gonna be supplementary angles. So that means this guy is supplementary, so 180 minus 103. I can't read that, so I'm gonna change it to orange. 77 degrees. So angle, measure of angle S is 77 degrees, which means the measure of angle R is also 77 degrees. All right, number two. So yeah, that's all over there. Okay. Number three, scrolling. Number three, a square has vertices 2, 2, 5, 2, 5, 5, and 2, 5. It is translated 4 units to the right. All right, P is 2, 2. So 2, 2 is right here. Q is 5, 2. Here's P, Q. R is 5, 5. There's R. And S is 2, 5. All right, it's translated. So this rectangle is right here, or this square. It's also a rectangle. Probably should know that. Okay, we're going to translate that 4 units to the right. So everything goes over 4 units. So P goes 1, 2, 3, 4. So here's our new P, P prime. Here's our new Q. 4 units to the right of that is Q prime. Here is S prime. And here is R prime. And I'm sure you're watching a lot of Amazon Prime. Prime joke. Okay. All right. So what are the coordinates? Okay. So P prime, it's fun to say, is, let's see, that ended up at 6, 2. Q prime ended up at, what is that? 10, 2, which kind of makes sense because all we're doing is adding 4 to the X value. Okay. And then R prime is 10, 5, and S prime is 6, 5. I had like an allergy doctor when I was a kid. His name was Dr. Tarnopolsky, and I think he was from Germany. I'd have to get these shots, and then he'd measure the reaction, and he was like 5, 5, 4, 3, 5, 5. Anyway, I miss him. I don't think he's still alive, because that was like 30 years ago, and he was already well in his age. Rest in peace, Dr. T. Number 4, we're gonna add these vectors in the diagram below. Well, this just goes down 2, and then it goes down 3. So when you add those together, you're really going down 5. So what happens when you go down 5 from the origin? So you end up at 0, -5. Okay, so this looks kind of like an ordered pair, but it's not. This is just in vector form, okay? So this is where you end up, where your terminal point for that vector is 0, -5. Number 5, we're also gonna go down to our graph, and we're gonna reflect this guy across DE. Well, you know what? We could probably just do it right here. So let's pick a color. What color? Let's go green. Okay, and we're gonna reflect this object, and it doesn't have to be perfect, across this mirror here. All right, we can do that. So it looks like we're going this, like that, and then this guy goes up a little bit over there, comes down like this, and then it looks like a little whoop. All right, so it's not perfect, but it's the right idea. So do something like that and you'll be fine. If you wanted to, you can label these because it's fun. B prime, C prime, A prime. That's technically what you should write as your answer, but give me the right idea and I'll give it to you, okay? Congratulations. All right, moving on to number 6. All right, number 6, we're gonna find the perimeter of the triangle shown below, okay? So, let's see, that's a 30, 60, 90 right triangle there. Okay, so remember this guy to get from here to here of x. So remember we have to multiply x by radical 3 to get to that 5. So to go backwards, you have to divide by radical 3. So 5 divided by radical 3, which is, of course, a no-no. If you write it like this, I'll probably give you credit, but I will maybe put a frowny face, which isn't good. It's never good. Okay, so to rationalize that denominator, we have to multiply by radical 3. Whatever you do to the bottom, do to the top. So you get 5 times radical 3 on top, and then radical 3 times itself is just 3. So x equals 5 radical 3 over 3. All right, and then y is always going to be twice the short leg. Y equals 2x here. So if x is 5 radical 3, so if 2 times 5 radical 3, or x equals 5 radical 3 over 3. So then it's just going to be 10 radical 3 over 3 for y. Okay, boom, we're done. Yeah, oh, I just realized that we have to find the perimeter in number 6. So perimeter is equal to all the sides added together, right? So we have our x, which is 5 radical 3 over 3, plus our y, which is 10 radical 3 over 3, plus our only side that's given is 5. Okay, well, let's add these fractions together. So we get 15 radical 3 over 3 plus 5. Well, this just reduces nicely to 1 and 5. So this final answer for perimeter, 5 radical 3 plus 5. That's our perimeter. Cool. Number 7. I never got a 7 on my allergy appointment. That's unheard of. No one gets 7s, but 5 was probably the biggest one I've gotten. I'm going to use the apothem and perimeter to find the area of a regular hexagon with side length 8 feet. Okay, so hexagon looks like this-ish. Actually, hexagon, all right, wait for it. Wait for it. You know what I'm doing here. Hexagon. Pow. Oh, that's pretty. That is real nice. I'm so cool. So this is 8. So we're going to find the area of this. So to find the area given the apothem and perimeter, it's just 1/2 times P times A. So 1/2 the perimeter times the apothem. Well, what's the perimeter? Well, if one side is 8, the perimeter is going to be 8 times 6, 48. So 48, and then what's the apothem? So the apothem, remember, is from here to here, right? There's the apothem. So if that's A, what? So if I blow up this version here, this is what this looks like. So the apothem is that kind of like the radius-ish thing of that hexagon. So if this is a 4 and this is a hexagon, so that means this is a 30-60 right triangle. So if this is 4, that's 8, and this is 4 radical 3. Okay? So the area equals 1/2 times 48 times 4 radical 3. Okay, so let's do that. Area equals 1/2 48, 24 times 4 radical 3. So let's see, 24 times 4 is 96 times radical 3. So that's the nice answer, and I would say square feet. Or if you want to multiply that out, square root of 3 times 96. It's about 166.28-ish square feet. Okay, but this is nice because it's the exact number. All right, good. All right, a rectangular tabletop has diagonal braces as shown below. If MQ is 3 feet, what is the length of NP? So if this part is 3 feet here, okay, well, we're going to use our properties of rectangles that say the diagonals bisect each other. So if this is 3 feet, this is 3 feet. Remember, the diagonals cut each other in half. So if this is 6 feet, then NP is also going to be 6 feet. Okay, so 6 feet is the answer to number 8. Number 9. Use a calculator to evaluate the expression cosine of 51 degrees. Okay, round to the nearest hundredth. So if you have a fancy calculator, you can just write cosine 51, enter. If you have a lame old iPhone calculator or whatever, you have to type 51 and then hit the cosine button. So to the nearest hundredth, that's 0.63-ish, right? 0.63-ish. All right, number 10. In the diagram below, AD and BC are internal common tangents to circle E and circle F. Find the lengths of AG and BG. Okay. All right, so we're just going to use our guts here. So these are both tangents. So we're going to find the length. We're going to use the fish method.
I just don't get it.
And it'll work out. So if this is 2x minus 5, this is x plus 1. So these two have to be equal to each other since they're tangents to the same circle. And these two have to be equal to each other since those are tangents to a circle as well. So 2x minus 5 equals x plus 1. Let's solve for x, get rid of the smaller variable. So x minus 5 equals 1. Add 5 to both sides. X equals 6. Then we're just going to plug in 6 for 2x minus 5 since AG is 2x minus 5. So it's 2 times 6 minus 5. 12 minus 5 is 7. So AG equals 7. And BG has to be the same length. Boom, number 10 is done. All right, number 11. So in the diagram below, use the angle of elevation between the flag and the person to find the horizontal distance between the flag and the person and the height of the flag. How about I just find X and Y? Okay, so X and Y, here we go. To find X, you can use the cosine, and to find Y, and you can use the sine. So let's just write out our formulas for sine and cosine. So sine of 26, remember, sine equals opposite over hypotenuse, or SOHCAHTOA. So opposite of 26, what's across the pond from 26 is y. So y over hypotenuse, which is 80. Okay, so to solve for y, you have to multiply both sides by 80 times 80 times 80. So y equals 80 times the sine of 26. Well, you know the sine of 26 because you have a calculator. So let's do that. 26 sine times 80. So y equals 35.07. 35.07. Y is approximately 35.07. All right, so how do you find x? Well, you could use the Pythagorean theorem from here. I think it's faster just to use cosine. So cosine of 26 equals adjacent. So remember, the adjacent side to cosine is whatever side is touching that angle that's not the hypotenuse. So x, adjacent over hypotenuse, so x over 80. So to get this guy by itself, you multiply by 80 on both sides. Those cancel, and x equals 80 times the cosine of 26. Well, what's the cosine of 26 times 80? 71.90-ish. Okay? And that's an approximation because we rounded. Now that looks ugly. X is approximately 71.9-ish feet. So our height of the flag is 35-ish feet, and the distance between that dude's head and the base of the flagpole, whatever, 72 feet, approximately. Congratulations. Okay, so number 12. Calculate the surface area of a regular hexagonal pyramid with a slant height of 9 meters and a base side length of 4 meters, okay? So the surface area in a regular polygonal pyramid looks like this. So it's basically the area of the base plus the lateral area, okay? So let's look at the area of the base. Area of the base is just gonna be 1/2 perimeter times apothem, and the lateral area is 1/2 perimeter times the slant height. So let's figure out the perimeter first. The perimeter is, what do we got? Hexagonal pyramid. So 6 times the length of the side is 4 meters. So 6 times 4 is 24. So there's our perimeter. So 1/2, 24. And our apothem is just gonna be, all we're doing is taking half of this a side length and throwing a radical 3 on it. Okay, if you don't remember, this is your hexagon. Your apothem is right here. And then this forms a 30-60 triangle. And if this is 4 here, then this is 2. And on a 30-60 right triangle, that's gonna be 2 radical 3. So that's your apothem. Plus 1/2 perimeter, that same perimeter, times your slant height, which they give you is 9. All right, so let's do that math. So this is 12 times 2, so that's 24 radical 3 plus 12 times 9 is 108. Okay, so you could leave it like that. That looks pretty. And what is it, meters? So this is square meters because it's surface area, or you could multiply it out. So 3 square root times 24 equals that guy plus 108, which is to the nearest 100th, 149.57-ish square meters. And that's ish, right? Okay, well done. Okay, number 13, write the equation of a line that is perpendicular to y equals 4/5 x and passes through the point 1210. Okay, so perpendicular to y equals 4/5 x, that means that all we're gonna do is flop that and negate it. So negative 5/4 x plus something. So now we have our slope of our new line. Now we need our intercept, our b. So to write an equation, you need the slope and you need the intercept. So what we're gonna do is we're gonna plug in a point, these xy values into here. Okay, so y is 10. So 10 equals negative 5/4 x, which is 12, plus b, and we're gonna solve for b. All right, let's simplify this. I'm gonna just cross reduce here. So 10 equals negative 15 plus b. Solve for b by adding 15 to both sides. So b equals 25. So now we have our slope and our intercept. Remember, b is just our y-intercept. So now we can write our equation. Y equals our slope, which was negative 5/4. We found that out by it was the negated reciprocal of a line perpendicular to it, plus our y-intercept, which is 25. So here's your answer to number 13. All right, number 14. To find the volume of a right prism, its area of base times height. Okay, the base is a 4 foot by 6 foot rectangle. Okay, so how do you find the area of a rectangle? 4 times 6 times the height, which is 3. 24 times 3 is 72 cubic feet. Boom. All right, number 15. In the diagram below, B is a point on circle A. Write the equation of circle A. Okay, so this is one of our new lessons. To write an equation of a circle, you need the radius and you need where the center of it is, okay? If I wrote this, so x minus x value of the center squared plus y minus y value of center equals the radius of that circle squared, okay? So this is the equation of a circle. So here we go. The x value of that center is 1. X minus 1 squared plus the y value of that circle is 2. So y minus 2 squared equals the radius of that circle squared. So 2 squared. So that's just x minus 1 squared. You can leave it like this. Y minus 2 squared equals 4. That was cool. That was 15. Okay, number 16 we're doing down here, and here's what 16 says. We've got a rectangle where E is negative 1, comma 4. So negative 1, comma 4, there's E. F is 6, 4, so right there is F. G is 6, comma negative 1, so right there, there's G. And then H is negative 1, negative 1. Looks like a rectangle, so far so good. So here is my rectangle, okay? I want to find the perimeter. We did this stuff in pre-algebra. So count the units. That's 7 units. And count the units here. That's 5 units. So what's the perimeter? Equals a couple 7s and a couple 5s. Just 24 units. Number 17, find the perimeter of the triangle shown below. Okay. So it looks like we're gonna have to find all the sides first. So if this is a 45, 45 right triangle, right? This is 90, so this has to be 45. So that means these two sides are gonna be the same. So this is 14. And the shortcut, if you don't wanna do the Pythagorean theorem, is just to tag on a radical 2. So the perimeter equals 14 plus 14 plus 14 radical 2. So perimeter is 28 plus 14 radical 2. You can leave it like that and say meters, or you can multiply it out, which is what I think they do. So let's do that with our calculator. So square root of 2 times 14 plus 28 is 47.798. So we're gonna round that to the nearest tenth, 47.8-ish meters. Okay? All right, number 18, I'm gonna order the sides from least to greatest. So let's figure out these angles first, okay? So let's see here. They all have to add up to 180. So we're gonna say 180 minus, that looks like 102. So that equals 78. So this is gonna be 78 degrees. We don't really need to know that, but we need to know which one's the smallest angle, which one's the biggest angle, and so on. So that means this side across from the smallest angle is gonna be your smallest side. So if I order them from least to greatest, I'm gonna say YZ is the smallest, And then I'm gonna across from 58, so that's XY. XY is gonna be the next smallest. And then across from 78 is our biggest one, so XZ is our biggest. All right, number 19. The perimeter of triangle ABC is 24 inches. Angle A is congruent to angle B if AB equals 10 inches long. Determine the length of segment AC. Okay, I'm gonna draw that triangle, okay? So if A and B are the same, then let's see. So if this is A and this is B, they're congruent. Here's C. So the perimeter is 24 inches. We'll come back to that. AB is 10. Ooh, look at that. Look at that typo. Anyone else see that? Segment AB equals 10. You're supposed to say measure of segment AB, not segment AB, or you could say AB. Typo. Shame on you, geometry, Saxon. Okay, so if this is 10, and the whole perimeter is 24, well, we do know that these two are the same, so we're gonna say 10 plus these two sides, x plus x, equals 24. So 10 plus 2x equals 24. You could probably just figure this out yourself. So x has to be 7. All right, let's just check that to make sure. All the sides, so if this is 7, and this is 7, 10 plus 7 is 17, plus 7 is 24. Boom, done. All right, number 20, last one. Here we go. In the diagram below, reflect DEF across the y-axis. Find the coordinates of the vertices of the reflected image and write the transformation and mapping notation. Okay, so let's do that. Okay, whoa, I know it's weird. It's over here. Everything's backwards. What are we gonna do? So first step is to reflect DEF across the y-axis. So that means this guy right here is gonna be E prime. This guy right here is gonna be F prime. And this guy right here, let's see, 1, 2, 3, 4. 1, 2, 3, 4 is gonna be D prime. All right, so this is what our new triangle looks like. And then it says find the coordinates of the vertices. Okay, no problem. D prime is, let's see, so 8, 4. The graph is everything's doubled, so it's weird. All right, and then E prime is 2, 6. Remember, each line is 2, so that's 2, 6. Don't say 1, 3. And then F prime is gonna be 4, 2. And then it says write the transformation and mapping notation. So our transformation, x, y, goes to, well, how does x change? Well, x just oppositizes, right? So we're gonna go negative x. So really the opposite of this x value is this x value, the opposite of this x value, and so on. All right, and then the y just stays the same. So that's easy. All we have to do is negate the x. So the transformation of D is at -8, 4. That's gonna go to D prime, which is +8, 4. All right, let's do E. E is -2, 6 goes to E prime, which is +2, 6. And then our last one, F, which is at -4, 2, goes to our F prime, +4, 2. And that's it. That's how you write out a transformation. Okay? Guys, that was test 15A. All right? If you understood that, then you're gonna do fine on 15B. But let me know if you have any questions. Have fun. We'll see you. Well, we won't see you. How sad. We'll see you in my dreams. That's creepy. Okay, we'll talk to you later. Bye-bye now.
Black man!